Hello, and welcome to this edition of Applied Geometry and Trig. Today I'll be your host, Colin Doolittle. Unit 34 is what we're going to cover today. I don't particularly care for the way that the PowerPoint goes and kind of the explanation of the book gives, so I'm going to kind of break it down into a simpler sense so we can work on it together. And instead of the homework in Unit 34, I'm going to send you out a worksheet that you're going to complete and then turn back into me. So really what Unit 34 is talking about is SOHCAHTOA, all right? It is dealing with triangles when they're right angles and being able to figure out either a side as an unknown or an angle that is an unknown, basically things that we can't figure out with just the Pythagorean theorem, okay? We call it SOHCAHTOA, so it's S-O-H-C-A-H and T-O-A, okay? So the SO is sine is equal to the opposite over the hypotenuse. And remember, the hypotenuse on a right triangle is what? Yes, that's right. It is the longest side, and it's also opposite the right angle. Brilliant. You guys are doing brilliant today. Ka would be cosine is equal to adjacent over hypotenuse. All right? And I'll explain the opposite and adjacent here in a second. And then the TOA is tangent equal to opposite over adjacent. So we're going to live in this world today. You're going to live with these functions, okay? So is sine equals opposite over hypotenuse. Ka equals cosine is equal to adjacent over hypotenuse, and TOA is tangent is equal to opposite over adjacent. At this point, you should pause the video and write this down. You're going to refer to this a lot. Glad you paused. We're back. All right. So let me draw you a triangle. I know how much you guys love my triangles and how spot on they are. Like, ooh, look at that. That's almost the right triangle. We'll go with the right triangle. Okay, so I'll label it A, B, and C. All right, so right here, we're looking at, that is a funky looking B, but we'll go with it. All right, right here, we're looking at a right triangle. So if I asked you what the hypotenuse was, you would all be like, oh, the hypotenuse is B, because it is opposite of that right angle. You'd be correct, okay? So now, how do I determine what is adjacent and what is opposite? Well, it's dependent on what you are looking at. So if I look at right here, I'll call it angle 1, all right? Opposite of angle 1 would be A. A would be opposite of angle 1. And then the adjacent, because it's right next to the angle, the adjacent would then be C. C would be adjacent to angle 1. All right? So that kind of makes sense. But let's say we're going to change it up a little bit. Just learning the new toy, so bear with me. All right, now we're going to say this is angle 2. All right? Now, the opposite of angle 2, okay, in relation, all right, is going to be C. And the adjacent to angle 2 is going to be A. It's all relative. It's all depending on what you're looking at and what you're looking for. If you hear squeakies in the background, it's my wife trying to be super sneaky, but she's not really effective at it, and she's not very ninja-like. So, all right, so hopefully this kind of explains the whole SOHCAHTOA thing. And then we're going to now just work some examples of what this is. And again, I will pause, or actually you should pause, and write this down. This is good stuff. We're super excited about it.
And I can be a ninja.
And she can be a ninja. She wishes. All right. So we've paused, right? You guys pause, right? I can see you. You don't even know it, but I can. Moving on. All right, we're back. So now let's look at this worksheet. It was nice of Mr. Duncan to create this worksheet for us that I ripped off the web. So it's pretty sweet. So let's look at the first one. It says, find the value of each trigonomic ratio and express your answer as a fraction in lowest terms. So this just wants you to understand, do you understand SOHCAHTOA? All right. So it says the sine of C. All right, right here, sine of C. All right, we got C. It wants to know, all right, what are we looking for when we look at sine? Oh, that's right. So, opposite over hypotenuse. All right, well, let's see. The opposite of C is going to be right there. It's going to be that 21. And the hypotenuse is going to be 29. It's opposite of the right angle. So, it says opposite over hypotenuse. All right. That's all it wants. Look at that. Sine. Cool. Now, here we got sine of C again. Same kind of setup. All right. What's our hypotenuse? Correct. 50. Good job, guys. That's going to be our denominator. And then what's opposite of C? 30. Very, very good. And that can actually be broken down to 3/5. Okay? That's all it's asking for. So I'm going to give you a second to do cosine. Remember, cosine is what? Adjacent over hypotenuse. Very good. Very good. All right. So I know you already have whipped this out, but just to refresh, we're looking for C there. Now the adjacent side is the side next to it. All right. So right here, this 36 is going to be adjacent. So 36. And our hypotenuse, 39. And that breaks down to 12 over 13. Sweet. You don't have to reduce, but I always like to reduce. It's good math practice, I guess. All right. Cosine of C here. All right. Now, what are we looking for? Adjacent hypotenuse. Hypotenuse, 17. Longest side, across from the 90. And then our adjacent side is going to be 8. 8 over 17. Cool. Finally, we're coming to our tangent. Tangent is opposite over adjacent. We aren't using the hypotenuse in this. So what's the tangent of A? What is opposite of A? 12 is opposite of A. What is adjacent to A? Hey, 35. 12 over 35. You guys are like getting the hang of this. Wow, you're just rocking it. I really appreciate that. Tangent of X, there's X. We've got our opposites. We've got our adjacent. So, we're going to be 36 over 27. 36 over 27. That is opposite over adjacent. So this is just, hey, how's this function? How does this work? How does this crazy SOHCAHTOA thing set up? So this is the basic setup. All right, so we're going to take it up. We're going to kick it up a notch. Take it up to the next level. Now, this is just about using the sine key or the cosine key or the tangent key, which you did do last chapter. But just as a refresher, so all this wants is the decimal equivalent of sine of 62. So for my calculator, I type in sine 62, enter, and I come up with, I'll go to 10,000th, so 0.8829. That's what I got. Why don't you try number 14 real quick on your own? Sine of 14. Brilliant. 0.2419. I concur. I got the same answer. And we're going to do cosine of 60. 0.5. Cool. Cosine. Oh, hey, as we're doing this, make sure that your calculator is in degrees. I know some of you that are taking college algebra might have your calculator, especially scientific calculator, in radians. For this, it needs to be in degrees. All right, so now we're going to do the cosine of 31. Gives me 0.8572. 0.8572. That's working out well. All right, and then let's look at our tangents. Okay, tangent of 79 is equal to 5.144 1446, and the tangent of 25 0.466.4663. All right, so we should all have these answers, right? If not, raise your hand and I'll stop. Well, I don't see any hands raised, so I guess we're moving on. All right, next section. Oh, now it wants us to find the missing side. Okay, here is our setup. Okay, so I'm going to expand this even more, make it bigger. All right, so they give us an angle here, all right? We've got a side, which the side is the hypotenuse, and we're looking for x, okay? So what, in relation to 59, what side is x? Is it adjacent or is it opposite? Adjacent or opposite? I would call that opposite. So since we know we're dealing with the opposite and hypotenuse, what function are we going to use? Correct, sine. So we're going to set this up. Sine of 59 degrees is equal to x over 17. All right, so how are we going to find out what the answer is? We'll bring the 17 up, so it'll be sine of 55 degrees. Okay. Hey, how about 59? See, it's like we're just in class. You know, I just randomly pull out numbers. All right, times 17 is going to equal x. So if I do sine of 59, close my parenthesis, times 17, I find x to be 14.6. Now, could I find this side as well? Yes, I definitely could find that side as well, but how would I do it? How could I find that side? Well, now I've got tools I can use. I have the Pythagorean theorem, of course, invented by my great-great-great-grandpappy, Pythagoras Doolittle. Or we could also use trigonometry, and that's what we're doing right now. So I'm not going to do it like ask you to do it, but we could. All I'm saying is we could. All right, so let's look at 14. Everybody pause your video, erase, or write down notes while I erase. All right, we're over here. Wants to find x. X is, and we're getting a degree of 60, and we've got a hypotenuse. This is opposite. So again, we're going to use sine. I'm going to set it up the same way. Sine of 60 degrees is equal to x over 17. Wow, we're just going to do 17 again. Weird. So bring the 17 up. So it's sine of 60 degrees times 17 equals what? All right, let's see what it does. I'm pretty sure it's going to be close to 14.6. So sine of 60 times 17 equals, and math print, let's try that. Sine of 60 times 17. 14.7 as well. Well, look at that. But yeah. So for 15, what do we have? Okay, we're looking for x here. X is next to that 27. So what does that become? Oh, that's adjacent. That's adjacent there. And we still have our hypotenuse. So we're going to go, all right, let's set it up. We have cosine, because adjacent and hypotenuse, of 27 degrees equals x over 20. Look familiar? Huh? Kick it up there. Great. So we'll have cosine of 27 degrees times 7 times 20 equal to, let's see, cosine of 27 degrees times 20, 17.8. 17.8. And then this will be another cosine function. All right. So you should try that. So the cosine, let's see. Oh, this is slightly different. All right, cool. So here, oh, let me erase. Maybe that doesn't really matter, but okay. So here, now we definitely have an adjacent side and we have a hypotenuse. But now it becomes cosine of 51 degrees is equal to, we have the adjacent 10 over x. All right. So we want to find the hypotenuse. All right. So that means that's got to go up and the cosine needs to come down. So our new setup is going to be 10 over the cosine of 51 degrees is going to be equal to x. All right. And then 10 divided by cosine of 51. And I got 15.9. 15.9 for the hypotenuse. And remember, if the number becomes out less than your any given side when you're looking for the hypotenuse, then you did something wrong. All right. Finally, here's our tangent setup. I'll just do one real quick. 40 degrees. A tangent is opposite over adjacent. So we've got tangent of 40 degrees. Opposite is equal to 20 over x. So that's going to become 20 over tangent of 40 degrees is equal to x. And 20 divided by tangent of 40 degrees. I have 23.8. 23.8. Okay, 23.8. All right, and then you should be able to finish up this tangent one on your own. I hope this is making sense. It's all set up. It's making sure the hardest part for most people is just identifying sides. What's opposite, what's adjacent, and getting that kind of mixed up in your minds. So don't get it mixed up. All right, now we're going to get into something a little bit different. Same type setup, but instead of finding a side, we are now looking for the angle itself. So we have here what are we dealing with? To this angle, we have opposite up. And we have hypotenuse. So what function is that going to be? Correct. So we have the sign of question mark degrees is equal to, okay, set up 39 opposite over hypotenuse over 44. Now, in order to make this work, you're going to do 39 over 44. So 39 divided by 44 gives me something like 0.8863. Okay? Now, in order to, if you put this in and type sine 0.88636, enter, you're going to come up with something like 0.015469283. All right, you're going to come up with a very small angle if that's what you think it actually is, but it's not. This is where our arc sign comes in handy. We are going to take this number and we are going to arc sign it, okay? So now, I'm going to do arc sign. Do my arc sign, put that in there. Now it comes up to 62 nearest degrees, 62 degrees. Okay, so that is now 62 degrees. Then you can find that third one super easy. All right, again, here I've got this angle. What's opposite of the angle? 26. Opposite of the 90, 33. So it's going to be, the way I put it in my calculator is sine -1. Because when I'm looking for an angle, I know I'm going to use the arc equivalent of the function. So sine -1, I'm going to say 26 over 33. Close that parenthesis off. So let me do that. Sine -1, 26 over 33. Close your parenthesis. 52 degrees. That is 52 degrees. Right? Let me get that. Cool. These are going to be cosine. And then these are going to be tangent. So I'll let you take a second to try to work these out. Oops. Okay, cosine -1, parenthesis, we're at 24 over 36. Cosine to -1. And we're going to do 20 over 23. All right. Tangent down here. We are going to do tangent to the -1. Opposite would be 10. Adjacent 33. And over here, we're going to do tangent to -1, 13 over 16. All right? And then you should be getting your answers. All right? And the answers, I'll pass out this worksheet. I'll give this to you guys. Will all be down here anyway, and all that good stuff. Now, everybody's favorite problem. So this is all for this right here. They just want you to put the arctangent number in. So this would be sine -1 of 0.7547. This would be, down here, it would be cosine of y. So it would be cosine -1.573336. And, put it in. So, like, so it's 0.7547. Oh. 40, I don't know what to say, around to what nearest degree. So 49 degrees. Cosine of -1. Sec cosine -1. 0.5736. Enter. 55 degrees. And so on. Just follow the directions. That's all at once. Now, we come to everybody's favorite problems. That being the story problem, right? I strongly suggest for any of these, you draw a picture. Draw a picture. Draw a picture. Did I say it enough? Draw a picture. All right. So we got an airplane. Don't judge my airplane. Okay, you can judge it pretty hard. That's a pretty bad airplane. I have an airplane. It's flying at an altitude of 6,000 meters. 6,000 meters. All right? Over the ocean. Woo, there's ocean. Yay, look at the ocean. It's pretty. Okay, cool. The angle of depression to the coastline from the airplane is 14 degrees. All right, so let's draw a building. Big building. Yeah, looks like a person. I don't care. There's another building. Maybe it's a little house. Door. Yeah, okay. So it says an airplane's flying at an altitude of 6,000 meters over the ocean directly toward the coastline. At a certain time, the angle of depression to the coastline from the airplane is 14 degrees. How much further to the nearest kilometer does the airplane have to fly before it's directly over the coastline? So I'm going to draw a line. That's going to be 14 degrees. We know that this is the hypotenuse, okay? And what are we looking for? We're looking for how much further the nearest kilometer does the airplane have to fly before it's directly over the coastline. All right, so we're looking for this down here. Now, we have this angle, we have this side, and then we're looking for with a 6,000 side. And actually, they want it in kilometers. So 1,000 meters is a kilometer. So I'm going to go ahead and change that to kilometers right now so I don't forget. So I'm just going to erase that. And now it's 6 km. All right. Well, I have opposite. I'm looking for adjacent, and I have a degree. So let's set it up. All right. Tangent of 14 degrees is equal to, our opposite is 6 kilometers over x. All right. Well, that's our setup. So how are we going to do it? We're going to rewrite it. 6 over the tangent of 14 degrees is equal to, drum roll please, 6 divided by tangent of 14 degrees, 24 kilometers, 24 km. And that will do it. All right. So these story problems, work through them, draw a picture. And in this, the answers are all on the back of the worksheet. So you can go ahead and follow along, maybe write notes on the worksheet. Then I'll send you another worksheet for practice problems to work on as well. I hope this helps. I hope this is a little better than the way the book explains stuff and all that good stuff. And if you have any questions, of course, I will be on tomorrow evening. I may shoot out a Zoom link to you guys. So if you guys want to meet up and just talk about stuff as a group, we can do that. I think I might just do that. So I'll send out a Zoom link tomorrow, and we can kind of talk about any questions that you might have. But try the problems, watch the video first, and there we have it. Hope you guys have a good rest of your weekend, and talk to you later. Bye.